Good evening. This is Saturn, photographed from close range. Since our last Sky at Night programme, the space probe Pioneer 11 has flown past the ringed planet. It wasn't originally designed to photograph Saturn, but it's done so, and it's sent back pictures which are surprisingly good, as well as a great deal of fascinating general information. Saturn's even more interesting than we believed it would be. And welcome back at this stage to Dr. Gary Hunt of University College London. I imagine, Gary, you're pretty pleased.
We're very happy, Patrick, because this has been a very important piece of information to safely get a spacecraft by Saturn. We did not know, in fact, how dangerous the rings would be, would there be much material beyond it. Not only does it mean that we've learned about Saturn for this mission and the opportunity next year with Voyager, it now has unlocked the opportunity now to look at Uranus and Neptune during the next 10 years. So this is a very dramatic landmark in the exploration of the solar system.
Well, Pioneer 11 has certainly done its work. And of course it's a strange spacecraft in some ways. It has some rather novel features. Nuclear power plants, I mean, you can't use solar panels out there.
No, in fact, going away from the Sun, if we have 100 units of sunlight reaching the Earth, I'm afraid only 1 unit will reach Saturn. So we need electricity to power the experiments, and we take our own systems with us on, in fact, this spacecraft here. Now, if I turn this round, Patrick, I can point out some of the important things that we can actually show on this very good model. On the back of this big dish, the dish is where we use that to send back the data back to the Earth. There are a set of cells, and these cells record impacts. Impacts, in fact, release gas, and we know that there have been collisions with tiny fragments of material nearby.
Yes.
And we had collisions about once a month between Jupiter and Saturn, but there were about 6 occurred within 24 hours at the time of closest approach. If I can now turn it round this way a little bit more, I can point out here, there's a set of instruments across the back here, and in particular this one here is the imaging system. It's a rotating spacecraft, and it rotates at about 5 revolutions per minute, and it produces a picture line by line. So it takes a long while to produce a single picture, but the spacecraft is moving very fast relative to Saturn. In fact, it can be moving at speeds as much as 80,000 miles an hour. So the ultimate picture you get is very elongated, looks like a rugby ball. And we have to use computers to reconstruct the picture, and therefore they're very different from the sort of pictures we've been used to with Voyager, which is taken at one instant in time. And furthermore, we are restricted on Pioneer just to have 2 wavelengths, 2 particular filters we can use to take the pictures, one in red light, one in blue light. So we have some limitations, but the pictures are extremely important, and of course they are the first time we have taken pictures out as far as Saturn.
What I find so intriguing is that when Pioneer was launched, it wasn't intended to go to Saturn at all. The story really begins in April 1973. When Pioneer 11 was launched. Now, this is a plan of the solar system, more or less to scale. Sun in the middle, there's the powers of the Earth and Mars, and then Jupiter and Saturn. Well, Pioneer went off on this journey, and it had a long voyage, and it bypassed Jupiter in December 1974, and sent back amazingly good pictures, the best of their time, better than anything before Voyager. And then, because everything had gone so well, it became possible to send the probe back across the solar system, first of all inside Jupiter's orbit, and then out as far as Saturn. And it made its closest approach to Saturn on September the 1st this year. So it's been a long time in space.
A long time, but of course there are problems too. It's one thing to send the spacecraft to Saturn, it's another thing to get the data back, because generally when we arrange an encounter with a planet, we try to make sure that the planet's in an important part of the sky away from the Sun, because the Sun has radio contamination, radio noise to itself, and it could in fact destroy this radio signal we're sending back from the spacecraft. And the problem we were having at the time of this encounter on September the 1st was that Saturn was very close to the Sun.
Almost behind the Sun, in fact.
And in fact, we did lose quite a bit of data. We had trouble with the weather indeed over California, and you know that we received data in the Californian deserts and in Australia and Madrid. So we had lots of problems getting the data back from the Pioneer, but in spite of that, we have learned a tremendous amount about the Saturnian environment and have got many, many good pictures as well.
Well, Saturn is a very long way away, but also, of course, it's a very large planet. In fact, Saturn is the biggest planet in the solar system, apart from Jupiter. Diameter is over 70,000 miles, and that's pretty big. It goes round the Sun at a mean distance of 886 million miles, and the Saturnian year is over 29 times as long as ours, although the day there is rather short, not much more than 10 hours long. Now, when you see Saturn really well from Earth, it is a superb sight. I think the most beautiful thing in the sky. Now, this was a picture taken from Arizona with a big telescope there in 1974. And at that stage, Saturn was really at its best. You can see there the globe, and that's not like the globe of the Earth. The surface is made up of gas, and inside there's a rocky core and probably liquid hydrogen. But Saturn is quite different from the Earth. Those rings are not solid or liquid sheets. They couldn't exist as close to Saturn as that. And the rings are made up of swarms of small particles, all spinning around Saturn like tiny moons. And you can see there that there are two bright rings separated by a gap called the Cassini division. Well, 1974, Saturn was really well displayed. At the moment, I'm afraid it's not. It doesn't rise all that time before the sun. It's still not well placed. It'll be better placed towards the end of the year. And at the moment, the rings are almost edge-on to us. So, seen from the edge, they appear only as a line of light, and in small telescopes you won't see them at all. So, for the moment, from the Earth, Saturn has temporarily lost its beauty. But it was a good time for Pioneer.
Oh yes, and in fact the pictures that we have taken have been particularly dramatic because even in that picture, Patrick, the best resolution we've ever had from the Earth is about 3,000 kilometres, and we've never seen any structure in the rings beyond the main divisions, which you pointed out.
Well, even when Pioneer was 3 days' journey away from its closest encounter with Saturn, you could start to see detail in the rings.
And in fact these pictures are really making history because we're now seeing close-up of Saturn for the first time. And one thing that really fascinates me, being a meteorologist, is the structure of the shadows that are cast over the equatorial region, because there are going to be parts of the planet which are constantly in shadow, and other areas which are going to be having sunlight shining upon them. So that the weather systems there are going to be very different, and really that's amazing. In fact, it is one phenomenon that occurs only on Saturn, nowhere else.
Well, those two black lines are, of course, the shadow of the ring. But going in closer, then you start to see detail on the disk itself. And you can start to see some of the belts, which are basically, I suppose, the same as Jupiter's in type, although they're not nearly so prominent.
Well, we can see them, we can just begin to see light and dark markings. These belts and zones, in fact, are slightly broader on Saturn than they are on Jupiter, and certainly seem to extend much further north, as far as, in fact, 60 degrees in each hemisphere. So, in fact, there are similarities between Jupiter and Saturn. Saturn is just paler, and it doesn't seem to be so dynamic. It's a much quieter atmosphere.
And of course, it's further from the sun, therefore it's colder, and you don't get the same kind of situation as you get on Jupiter.
Well, it may be that we have a less stable atmosphere, or in fact more stable atmosphere looking at Saturn, but I think this is important to us because now we're building models to construct the meteorology of Jupiter. They must be used to explain Saturn. If they don't work, we've got it wrong. So here is a good test for us.
But the best Pioneer pictures do show at least some detail on the disk.
Yes, we are beginning to see some detail here and also structure in the rings. I think this is the really exciting thing, is that as we've got closer to Saturn, we've seen a lot of structure in the rings that we've never seen before. This is where some of the amazing discoveries have been made.
And on that picture too, we can actually see Titan, the biggest satellite of Saturn, that speck near the bottom of the screen. And of course that's a big world, bigger than Mercury.
Yes, we really are then looking at the planet-sized object, and they are really the two prime targets in the exploration of the solar system to come in the next few years.
There's one thing that strikes me, Gary. The Voyagers, which have bypassed Jupiter and will bypass Saturn, are stable craft, but Pioneer is actually spinning round, and this must cause a certain amount of distortion when you take a close-range picture.
Well, in fact, we see a good example of this on the next picture, that we actually, with a spinning spacecraft, we get it built up line by line, and the jaggedness we see across this equatorial region is simply an indication of each line that's been used to construct the picture. In time, with the aid of computers, we can, of course, reconstruct the picture and cosmetically enhance it and take out those distortions. But these are pictures that have had very little computer massage, and as a consequence there is little contrast to be seen.
But when you look at the best pictures of Saturn, so far as the globe is concerned, I think we've got a pretty good picture now of what Saturn must be like. After all, it's so totally unlike the other flattened globe, which is spinning around so quickly, possibly with a rocky core and liquid hydrogen round.
That certainly seems to be our current understanding, but in addition to getting these pictures, we are getting details of the reflected sunlight. We'll be able to use these, for example, to examine the height contrast between certain parts. For example, we've already discovered from the temperature maps of Saturn that the equatorial clouds are higher and, as a consequence, colder than the surrounding areas, and that's an important new discovery.
You know, I remember some years ago when the pioneers were going through the asteroid belt, there was a good deal of alarm and despondency in the United States as to whether there was going to be any disastrous collision with a particle. Well, luckily that didn't happen, but I imagine there were more misgivings as Pioneer approached the rather dangerous system of Saturn's rings.
Well, literally, Patrick, we had no idea what was going to happen, and it's made worse. You and I are sitting here talking, or I can hear you exactly as soon as you speak, but if you're at Saturn, I have to wait almost 1.5 hours to know what you were saying. And as a consequence, this means that the time of closest approach on Saturn and passing the ring plane crossing, we would have to wait with bated breath to know whether it had been successful. And we all sat there chewing our nails early on that Saturday morning.
As Pioneer actually went through the ring plane.
And in fact, we can have a look now at a sketch that indicates precisely that the flight path that the Pioneer spacecraft used. It came at a slightly inclined trajectory towards the planet, and it went beyond the outermost ring, the A ring, and passed only 21,000 kilometers above that region, behind the planet, and then at a similar distance on the other side of the rings. And it was during that time there were about 6 direct hits. And there are several particles around about a micron, centimeter cross-section, which were colliding with the spacecraft.
There's one particular picture of the ring system that I think shows more than any other, and it does show there the detailed structure.
And to me, this is a moment of history, because in the outermost part of that ring, we're seeing new structure, and it does emphasize that as our resolution gets better, we're going to see that these rings have lots of structures in them. They aren't a single layer. They, in fact, do have certain divisions in the vertical as well. We think they're still a kilometre or less in vertical extent, but there are whole ranges of particles, probably about a centimetre in size.
And, of course, there are more rings than we thought. Useful, I think, to look at a bird's-eye view of Saturn. Just imagine you're looking right down on the Saturnian system. There's the gaseous globe in the middle, and round that is a fairly blank area. Then we come into a shaded ring, and that's the crepe or C ring, discovered way back in 1850, and it's semi-transparent. Then outside that, we have the brightest ring, ring B. Then we have the division, the Cassini division, so-called, was discovered by an astronomer of that name, which again is a fairly blank area. And outside that, we have ring A, which also is bright, although not so bright as ring B. And when you look at Saturn through a small telescope, under good conditions, not at the moment, of course, rings A and B do tend to merge into one. Well, now, Pioneer has shown us that there are new rings outside ring A, the so-called F and G ring. And although an exterior ring had been suspected before, it certainly hadn't been proved.
Well, we had some knowledge in 1966 of its presence, but the F and G ring, to me, are probably divisions within that additional ring that we thought existed beyond the outermost visible ring, the A ring. And in fact, people with large telescopes, we will certainly be looking from orbiting satellites, are going to look at Saturn in November, because again, that's a time when the rings will be edged onto us and we can observe the structure. But I'm convinced, Patrick, that we'll find a lot of detail when we look with Voyager in the future. But these rings are important from another point of view, and they indicate a problem we have, a problem of detecting the magnetic field of Saturn. Now, Jupiter is known to have a very strong magnetic field, and we did discover that the satellites, the main Galilean satellites, swept away the charged electrons and protons that existed around it. Now, the presence of the rings prevent the radiation belts forming in such a well-organized manner, and it's made it impossible for us to detect any radio signals from Saturn which would indicate the magnetic field. The Pioneer spacecraft has shown us for the first time that indeed there is a magnetic field for Saturn. It's a lot weaker than Jupiter's, about a 20th of Jupiter's field, and maybe round about sort of the strength of the Earth's field. So that's a very important discovery, and does indicate very important interactions between the ring particles and, in fact, the magnetic field.
We've heard a great deal about these zones of lethal radiation surrounding Jupiter, which make it a very dangerous place indeed. I would expect that you get the same kind of radiation zones around Saturn, but on a very much weaker scale. Am I right on that?
That's certainly the case, and of course, now, as a result of this flyby, we know that since the Voyager spacecraft survived Jupiter, it will also be able to survive Saturn. And in addition to those measurements, we have discovered, by looking at the densities of the electrons and protons, evidence for a new satellite. Well, at least we say it's a new satellite. There is certainly a lot of material around there. We've had arguments about Janus and possibly the 11th satellite of Saturn. There is the possibility that a 12th satellite may have been discovered, but I believe that we will discover many objects of about the 100-kilometre cross-section with the Voyagers in the next few years. So there may be a rich number of extra satellites to be discovered.
I would certainly expect so. And there's one other thing that intrigues me very much as someone who's been observing Saturn through telescopes on Earth for the last 40 or 50 years, and that's the question of the outer division in Ring A. And I think the best picture sent back from Pioneer of the rings will show what I mean. Let's have another look at it. Now, here, first of all, we have Ring B, that's the brightest of the rings. Outside that, we have the Cassini division. the black area, and then we have ring A. And look in the middle of ring A, you'll see a tiny curved line. And that is the so-called Encke division, reported by Johann Encke way back in 1820. And there's always been a discussion as to whether that is in fact a genuine gap in the rings, similar to the Cassini division, only less marked, or whether it's simply a ripple. Well, I think we now know that it is a genuine division. And of course, outside ring A, you can clearly see rings F and G.
I think, in fact, what we should now do, Patrick, is to compare this picture with the dramatic one taken by Voyager in July of the Jovian system of rings. We can see how different they actually are. The Jovian system is a problem to us because we've got material very close to Jupiter. It's a different system of rings. In fact, we believe that the material actually spreads right the way down to the cloud tops. We have no idea of the origin of the Jovian ring system, and in fact it may not be terribly stable in the same way as the rings of Uranus. But in the case of Saturn, those rings are probably due to material that's left after the actual planet was formed, and they remain stable because of the interactions with the satellites. So although we now seem to have three large bodies in the solar system with rings, Neptune may have rings as well, to me, Saturn is certainly the lord of the rings.
Oh, there's no doubt about that. I mean, it's a magnificent object. But of course, we shall know even more about Saturn's rings in November 1980, when Voyager 1 makes its pass. And that was intended to be a photographic probe, so far as Saturn was concerned. So I think we may expect great things from that.
In fact, it's useful to compare the trajectories of these two spacecraft because they are very different, and it indicates very special alignment of the planets that are taking place. If we go back then to the history of Pioneer, the launch in the early 70s and the encounter with Jupiter in 1974, that was quite a long fly path, and then it was nearly 5 years before the Pioneer spacecraft reached Saturn on September the 1st. So that really was sort of a bonus, and we're now reaping the benefit of that. The Voyagers, on the other hand, were specially designed utilizing the launch in 1977, the encounter with Jupiter in March of this year, and with the planets in this special alignment, which occurs about every 179 years, it's only 18 months between the Jupiter and the Saturn encounters. And in Voyager 2 now, as a result of showing that we can get a spacecraft by Saturn, will reach Uranus in 86, and who knows, Neptune in 89 or 90.
I see no reason why it shouldn't. You know, Gary, there's been a tremendous amount of sensational rubbish talked about this so-called planetary alignment. Well, there will be a rough lining up in 1982. Happens every 170 years or so. And I can assure you, it can affect nothing and nobody. So if you hear alarmist rumours about storms, earthquakes, etc., caused by the planetary alignment, you can entirely disregard them. I can promise you that. So there's no need to be alarmed about it. But of course, this alignment has been useful to the space planners.
It's saved us a lot of effort. We can send spacecraft to the outer solar system very, very quickly, and we don't have to carry a large amount of gas to alter the trajectory as we fly on. So we've utilized this, and we won't be able to do it again into at least another 179 years. It's a very long while in the future.
Well, Pioneer 11 has done its job. It had a success with Jupiter in 1974. It's had success with Saturn in September of this year. What's going to be its final fate, do you think?
It's certainly done everything in terms of encounters with the planets. It now is our messenger leaving the solar system, encountering perhaps with some other intelligent civilization. If it does, of course, we have got a plaque on the side to know where it's come. We should be very grateful to everybody associated with this mission for what it's done. It's certainly given us our first look at Saturn and unlocked the exploration of the outer solar system.
And how long will you be able to keep track of it?
Until about 1985, when it crosses the orbit of Pluto. So it will give us data for at least another 6 years.
Well, it's given us our fascinating first glimpse of Saturn, and I think it's done more than its makers dared to hope. It's been an outstanding success in every way, and now we look forward to November 1980 with the Saturn pass of Voyager 1. So for the moment, from Gary and myself, good night.
Good night.